This is the second of two videos that cover importing acquired logic analyzer data into a pattern generator. And as before, I'm using this companion document, which you can get here. In the first video, I covered the ASCII CSV format, which has an upper limit of 1 million vectors. A little more convenient than the second method that we're covering in this video, which is the binary format. And this gives you access to the full 16 meg vector limit of the pattern generator hardware. So if you need more than 1 million vectors, you do need to use this binary method. So I will go down the procedure here and show you how the file is created and what needs to go into the file for it to be properly recognized by the logic analyzer software when we go to import it. And it's worth noting that this example will show you how the files need to be structured, and you can certainly use this same method to generate your files, but keep in mind that if you'll be needing to generate a lot of these files, it'll likely make sense to write some code to do this for you so you don't have to do all the calculations and counting bytes and so on. But you can certainly use this method to generate the files. So let's go ahead and export this now to a module binary file. This will have a .alb extension. Again, I have some options here, and I want to make sure that my all data box is unchecked, which gives me access to these two buttons and this dialog here where I can select a subset of the data to export. And I also want to deselect anything that I don't want to export. So I'll click OK there, give this a file name, and it just created my .alb file in the export files directory. Now I want to open this in a hex editor so I can add in the binary header information. And so here we see the ALB file that was generated by the logic analyzer export. And I'm in step 11 in my procedure at this point. So I'm going to copy this to my clipboard, insert my cursor right at the very beginning of the file, and do a simple paste. And so I've got the end of the word begin, followed by a carriage return and a line feed. And at this very point right here, I want to insert the values from step 12. These are 32-bit integers representing the number of vectors, which is 4096 in my case, and the width of the vectors, also equivalent to the number of pods I'll be using, which is 1 in my case. And also worth noting, this is big endian format, and that is exactly what the bits will look like, or the hex values will look like, for my particular values of 4096 and 1, respectively. So at this point, I'm going to go into my editor, make sure I have the cursor at the exact correct position. I'm just going to right-click and do a hex insert, and insert 8 bytes. Now those are all 20s by default, so I'll just overwrite those 8 bytes with the values shown in the document. So I've got a pair of double zeros, 1 0, 0 0, 6 zeros, and finally 0 1. Now I'm ready to save this file, and I want to save this with a .pgb extension. And now I'm ready to import it. And if I did everything correctly, I won't see any errors. And in the import dialog, I'm going to select the pattern generator binary file, which is the PGB. And I'll navigate to the file I just created and import that. It'll take a moment, and it'll load those vectors into pattern generator memory. And then I'll run the pattern generator and confirm that the data looks as expected. Now when I go into my pattern generator setup, you'll notice that I don't have all the tabs enabled that I previously had, and the reason is that the sequence was created with a PGB file, as the message indicates here. So basically, the GUI limits you to 1 million points. It can't efficiently allow you to see and to edit all 16 million vectors, and that's just one of the limitations of this binary mode, but it is required for the full memory depth of the pattern generator. So I'll go ahead and do a repetitive run on this now. Now my vectors are being produced by the generator repetitively, And I can see that when I go into my bus signal setup and look at my activity indicators for my upper 8 bits of pod 1, and that's the pattern generator output. And the clock is also active for the pattern generator on the A2 clock input. My sampling mode, I want to change this to not use the clock from the device under test, but rather my falling edge of my pattern generator clock, and that's the clock output on the clock pod of the pattern generator. So I'll click OK there, do a new acquisition, and I want to focus on the lower part of the screen here where my pattern generator signals are displayed. And we should see the exact same thing that we saw before. Everything looks good so far. My trace of bus value versus time looks great. I don't see any glitches or anything. And so just eyeballing it, this looks to be an exact representation of the original data that I acquired. And again, you can use a compare tool if you like to go in and compare the data that you get out of the generator with the original data and confirm that there are no errors at all and it's identical to the data that you captured.